So let me start by acknowledging the traditional owners and custodians of the land on which we work, the Wurundjeri and Bunwurrung people of the Kulin Nation, and pay our respects to indigenous elders past, present, and emerging. We are very fortunate here to have John Cook. He did his PhD with Steve Lewandowski, same person that Dan did his PhD with. I think we all know who Steve is. Took up an assistant professorship at George Mason University, came back to Australia, did a fellowship at Monash, and we're very lucky that he's just joined the Behavioural Change Hub Workshop Center, whatever we're going to call it today, center, perfect. And that is delightful. And he was one of the stars at this very impressive launch that we just had last week. Famous for many things, including Cranky Uncle, climate change version, and later on vaccine version developed, being rolled out across the world. I kid you not, no exaggeration. So incredible guy. I will leave you there. Charles, do you mind just monitoring the chat on Zoom, because I can't, I've given up my views. Oh, I can do John, I can keep track of that as well.
Okay, cool. I was going to start my talk by talking up how complicated misinformation is as a problem solve, but after solving the last half an hour, I feel like we should be able to solve anything, right? So well, firstly, thanks to Andy for first inviting me, and Piers for hosting and doing a lot of problem solving. But what Andy suggested initially was that I talk about my research, and really the purpose of this is to just talk about what I'm doing, and then with the goal of hopefully sparking collaboration, conversations. So I'm not going to be just talking about one study, but more giving a broad landscape of a lot of different research that I'm working on through the lens of hopefully this will be something that's, because I know that there's a lot of people here working in a lot of different areas, so in different disciplines. So just to set the context. And my hope is just that people follow up with me afterwards and can have conversations by email or coffee or whatever. So the way I'm going to frame this or kind of organize this is my work has been focused on addressing misinformation, starting with climate change, still mostly climate change, but broadening to other misinformation in other topics. And because misinformation is such a complex and interconnected problem, I've found it necessary to form a lot of interdisciplinary collaborations. Like my discipline is cognitive psychology. I've mainly started by doing a lot of experiments, testing different interventions to counter misinformation. But that's really just one little piece of the puzzle. And the way I've organized my work is across 4 Ds. Detecting misinformation, deconstructing it to identify if it's misinformation and how it misleads, debunking it, testing and or developing and testing different interventions to counter misinformation, and then deploying it, partnering with what I call like communication practitioners, whether it's app developers, web developers, TV weathercasters, educators, just finding ways to get our interventions out to our target audiences. So these 4 Ds require working with researchers across a range of disciplines. And I'm just going to go through some of the different research projects that I've developed across these different disciplines. I'm going to start by talking about CARDS. This is our machine learning research with the goal of detecting and categorizing climate misinformation. CARD stands for Computer Assisted Recognition of Denial and Skepticism. We spent way too long trying to come up with an acronym that made sense. And this is done in collaboration with Travis Cohen at the University of Exeter and his PhD student, Miriam Nanko, and Konstantin Bousalis at Trinity College, Dublin. So what we did was, this was a paper we published in November 2021, where we trained a Roberta model using supervised learning to detect climate misinformation and identify what type of climate misinformation it was. To do that, the first thing we needed to do was develop a taxonomy of climate misinformation. And this is a simple version of it. I might just, is it possible to minimize? Because it's kind of blocking it. Yeah, I mean, if you just minimize it, that's probably sufficient. But, and the taxonomy actually goes down to 3 levels, but I'm only showing 2 levels here because otherwise it just gets too difficult to read the text on a single PowerPoint slide. But the key thing to understand about our taxonomy is there are 5 main categories of misinformation. The first 3 are the science-based ones. The first 3 categories of climate misinformation are the science-based ones. Global warming isn't happening. Global warming isn't caused by humans, and the climate impacts aren't that bad. The 4th category is focused on climate solutions, saying that policy is harmful or ineffective, or renewables are harmful or ineffective. And then the 5th category is attacking the science itself, or attacking scientists or climate activists. So that's about eroding public trust in climate science. And our method was, in a way, it was straightforward. It was about, once we developed our taxonomy down to 3 levels, we scraped hundreds of thousands of articles from 2 known sources of climate misinformation, conservative think tank websites and climate denier blogs. Then we just randomly selected paragraphs being a unit of analysis. And then we would just read through randomly selected paragraphs and map them to different claims in our taxonomy. And just do that tens of thousands of times. I think 28,000 paragraphs is what we labeled. And once we had done that and trained our Roberta model, we tested a lot of different models. Roberta, at the time, a year or so ago, was the best performer. Then we just ran our entire data sets through the model in order to construct a 2-decade history of climate misinformation. And what we found was that, firstly, with conservative think tank websites, the biggest category of misinformation was that 4th category, casting doubt on climate solutions. And also there was an increasing trend towards solutions misinformation. So climate misinformation is transitioning away from science denial towards solutions denial, which is kind of intuitive. As the science becomes stronger and stronger, it becomes more untenable to deny the science. So they just switch to solutions denial. The end goal was always the same. It's about delaying climate policy, maintaining the status quo. But whether they're arguing global warming is not happening, therefore we shouldn't act, or this solution wouldn't work, therefore we shouldn't act. It's always the same conclusion and goal. But we also found that attacking the science was another quite prominent category, and much more prominent than the science-based arguments. And that was interesting because most of the work in climate misinformation is about those bottom 3 categories, debunking myths about whether global warming's happening or whether it's human caused. And guilty as charged, that's what I've spent most of my work on, is debunking all those science myths. That's actually a small part of the landscape of climate misinformation. When we looked at climate denial blogs, similar picture, but some interesting differences as well. The policy misinformation was also, sorry, do you have a question, please?
So I've got a question just about this. Science is unreliable. How is that different from it's not happening, it's not bad, it's not us? Because those 3 are all the science saying it's bad.
Yeah.
Science is unreliable is not different. So what would a paragraph have to be categorized as science is unreliable as opposed to one of those?
So the first 3 categories are arguments about the state of the world, like global warming isn't happening, or global warming is caused by the sun. It's kind of like saying we know what's happening, and this is our alternative explanation of. Whereas category 5, the attacking the science, was saying it's basically uncertainty arguments. We don't know. You can't trust the models. You can't trust the temperature data. You can't trust. So one might say, we trust the temperature data, but the data is saying cooling is happening. The other is saying we can't trust the temperature data. So it's more of a emphasizing uncertainty and eroding people's faith in what the science is saying. Often they mesh. For example, they will say global warming hasn't happened for the last 15 years, but the models predicted that, so you can't trust the models. So it's a combination of category 1 and category 5. Like we find that they often clump together these different arguments. Yes. Pardon, sorry? Yeah, we haven't done that yet. In fact, right now we're recognizing a limitation of our model was we use single labeling. Every paragraph was just mapped to a single claim, where often they do clump together like that. So we're in the process of converting our model to multi-labels now, which means we have to do a lot of recoding. That's a question we will struggle with in the next.
Would you think that if that is combined, would that be stronger? Like, would people be more inclined to?
Yeah, I mean, that's an empirical question. Like, one of the things I'm doing testing this year is like doing a lot of work on fallacies and how different fallacies might be persuasive. But then what happens when you combine multiple fallacies? Is that more persuasive? And then also when you're debunking them, do you just debunk one fallacy or do you debunk all the fallacies? So there's lots of interacting questions and they can be tested empirically, but that research hasn't been done yet. So yeah, these are very good questions. Yeah, so I think that's all I'll say about the blogs at the moment, but I just want to quickly touch, because I realize I'm running out of time already, but I want to touch on some. Oh, great. Yeah, it'll just depend on how much people's stomachs start grumbling, but we've also started applying it to social media now. We've worked with researchers in Hamburg who are constantly scraping climate tweets, and they've supplied for us 6 months of tweets, 3.1 million tweets, and we ran that through our machine. And firstly, we looked at just the percentage of misinformation over time, because the reason why we were doing this was because we were thinking when Elon Musk took over Twitter, he started putting all these, unbanning all these extreme right-wing climate deniers, and we thought our intuition was that might cause a change in the composition of climate misinformation on Twitter. We're not seeing any trend of that in the data. Like this is about 4,000 climate misinformation tweets a day, and we saw no sign of a Musk effect. Similarly, like in our original analysis, we thought there might be a Trump effect. Because once you go into the Trump administration in 2017, and then you had climate deniers in the EPA and just in very high positions of power, the Department of Environment, I think Rick Perry was. And again, all the trends seem to continue pretty straight. So this tells us that we think that the climate misinformation is quite stable. And in fact, it's stability over the last few decades that has enabled us to do this, because type of arguments we heard in the 1990s are the same arguments we're hearing in 2023, but they're just they're rebooting old myths, and like they used to argue global warming stopped in 1998. Now they're saying global warming stopped in 2015. It's the same argument. They're just like search and replace, they're old texts. The other thing we did was look at what are the most common categories of misinformation on Twitter, and 55% of the tweets were the fifth category, or a subset of the fifth category, attacking climate actors. So mainly attacking scientists, but also attacking environmentalists, journalists, and politicians who were involved in climate change. So, so across these different platforms, you see a different emphasis. Think tanks are about policy. Blogs are about attacking the science. Twitter is about attacking people. And so that's important too. If you're going to develop interventions on a specific platform, you'll want to tailor it to whatever the emphasis is on that specific platform. So yeah, that's it for that's all I was going to talk about with the machine learning research. Any other questions on that before I move on? Yes?
I was just going to say, with your changes based on like world events you were looking for and maybe just find it, did you consider like engagement as well? Because like often what happens, as far as I can tell with social media, is that the amount of posts being made about it doesn't necessarily change. It's more about how many people like to respond, like retweet kind of stuff, because of the hierarchy of, for every post and there's 100 people engaging, for every one there's 100 people just liking it.
Yeah, I mean, this captures. Yeah.
People on Zoom, would you be able to repeat the question?
Yeah, sorry, I was thinking that before and then I forgot to do it. So the question was, and hopefully I'll paraphrase this right. Like we're looking at the total number of tweets, but are we capturing engagement? Because you might have the same number of posts, but people are engaging more if it's an event, like it's a COP climate event in Egypt or some big climate like meeting happening or something, or it could be an extreme weather event that's affecting. We haven't gone that deep yet, other than the fact that total number of posts would include, my understanding is it includes replies to tweets as well. So I guess that's a proxy for engagement, but I think, yeah, there's a lot of scope for going deeper into this Twitter data. We've only just done a shallow preliminary pass on it so far. Any other questions on the machine learning before moving on? Yes.
Analysis is paragraph. Give a sense of how heterogeneous each document is. Like when we think documents, are they attacking the actors, attacking the potential solutions, and then also talking about the state of the world, or is it generally focusing one or the other?
Yeah, so the question was, given that our unit of analysis was paragraphs, what would you see across an article? Like, would an article be attacking policy and also attacking people, or making scientific arguments? Again, because often our paragraphs are quite long, and so when I look at the when I started doing the multi-labeling, like this isn't answering your question, but it kind of gets at the gist of it. I do see a lot of themes clumped together. For example, the argument that climate has changed in the past, therefore what's happening is natural, often combines with the hiatus argument that global warming stopped because we're in a natural cycle, and therefore what's happening now is just a natural cycle, and therefore you can't trust climate models. So you do see this run-on argument, and it'll jump from category 1 all the way over to category 5, and then they might bring in policy. Therefore, we shouldn't act, or we shouldn't enact these destructive economic policies that are going to, raise prices and destroy the economy. So yeah, I can't speak at the article level, but definitely within the unit of analysis, you do see these different themes coming together, and I'm hoping that when we publish our multi-label research, we can start digging into which ones are seen together, because that will help people make sense of the most common kind of sort of structures of arguments that are out there. So I probably should move on. But we can always do more questions at the end. It's very laborious training a model like this, reading through tens of thousands of paragraphs. That's also quite a difficult task. It requires climate literacy. It requires familiarity with misinformation. So you can't just, we tried actually, the first pilot was just getting some communication first years at George Mason University to do it. And the inter-rater reliability was worse than if chickens pecking at it. Like it was useless training data. And then we repeated the task with Skeptical Science, the community members, which is my climate debunking website. And then you've got a much higher reliability. So we realized you need skilled coders, and it's very time intensive. So just this is brand new, like just over the last week or two, we've been toying with the idea of using GPT-3 to train the model. And my first attempts at that weren't that productive, but some computer scientists at Monash came up with a clever method for, no, I don't, do I have a, yeah, they came up with a method where you could give GPT-3 3 examples of a particular claim. So in this case, it's one of those category 5 claims, casting doubt on the temperature record, and just grabbing random examples from our existing training set, and then ask it to generate a new one. And so what I found when is when you feed it a couple of real world examples and ask it to generate a fourth one, it often was quite good, and it often was not just mimicking the text, but it was coming up with a new angle on casting down on the temperature record. So it, like, GPT-3 is often criticized for not being good at generating accurate content. It's very good at generating bullshit, just because it's coded from a lot of the text that was used to train it came from misinformation sources. So the problem is, when I kept trying this, then I found that it was also creating claims that actually fit better with other parts of the taxonomy. So I'm asking it cast out on the temperature record, and instead it cast out on climate models. So I realized, okay, well, that you wouldn't want to use this text to train the model saying, hey, this is a temperature record claim. And so I think what we need to do, and again, like I said, we're in the early stages of this, is further refine the prompt to exclude claims in the taxonomy that are conceptually close but different. Basically, I think it is possible to generate a lot of content that could train the model, but it would have to be done with a lot of curation and careful design. So this is something we're going to be doing over the next couple of weeks, and we'll see. You look pretty skeptical, Piers?
I tried it. It's very hard. It's just what not to do. It just ignores you.
Well, I mean, my first exclusion criteria was without casting doubt on climate models, and it ignored that.
Yeah.
When I was more explicit. So I think a lot of the art of is the design of the prompt. But yeah. I can tell you in a few weeks how successful we've been. But if we can pull this off, then we don't have to spend months trying to find skilled coders and training the coders. Anyway, it's so if anyone has experience in this and wants to talk more about it, I would welcome any expertise. So that's what we're just playing around with in terms of using machines to train machines, which is how I think the Terminator movies might have started. But the third thing we're looking at is building our taxonomy of misinformation claims, because research was published after our research was done, going into more detail into policy claims, and these are often more values-based and difficult to categorize as explicit misinformation, but they're also quite effective in casting doubt on policy or delaying policy, just as arguments to say we shouldn't be doing, we shouldn't be acting on climate change because of these reasons. Like, for example, individualism is actually one of the most effective insidious forms of climate misinformation, because they've successfully gotten the environmental movement to internalize this. Like the argument that solving climate change is the job of the individual rather than societal change and transitioning to renewables was pioneered by the fossil fuel companies paying PR companies to develop carbon footprint calculators. So that was carbon footprint calculators was invented by the fossil fuel companies, and we've all internalized that idea of where the individual how to solve climate change. Like that's three-dimensional chess misinformation. It's brilliant, and it's but these kind of insidious things, kind of techniques, need to be addressed as well. So we're in the process now of trying to incorporate the discourses of delay into our taxonomy, so then we can detect them in different online texts. That's again in the very early stages. Any questions on that before we jump into our second part of the presentation? So deconstruct is about using well, it's been my collaboration with critical thinking philosophers to develop a methodology for deconstructing potential misinformation in order to A, determine is it misinformation, and B, how does it mislead? And this began with a study we published in 2018 with two philosophers at the University of Queensland. And what we did was we developed a methodology for taking claims, and this can be across any topic, but we applied it to climate misinformation, deconstructing it into an argument, which is a series of premises leading to a conclusion, and then assessing, is this argument logically valid? If it isn't, find whatever hidden assumption or unstated premise is in the argument to make it logically valid, because often it's unstated assumptions is where misinformation does most of its heavy lifting. And then once you have a logically valid argument, then you can go through all the individual premises and surgically pinpoint where in an argument is it misleading. This is a bit abstract. Here's a simple example. This was actually the argument that I studied in my PhD research, which was the Global Warming Petition Project. It's a website that has 31,000 signatories of a petition saying that humans aren't disrupting climate. And the point of it is to say, 31,000 scientists have signed this statement, there's no scientific consensus on climate change. When you deconstruct it into premises, the argument is basically saying that a large proportion of scientists dissent, and or a large proportion of science graduates dissent, and someone with a science degree is an expert in climate change. Therefore, there's no scientific consensus. That's the guts of the argument if you break it up into its individual pieces. And this argument is misleading on several fronts. Firstly, 31,000 is not a large proportion of science graduates. There are millions and millions of people with science degrees, and this is just in the US. And secondly, just because you have a degree in computer science, no offense to computer science, but or mechanical engineering or veterinary science or medical science, that doesn't automatically convey expertise in climate science. And so it's because over 99% of the signatories of this petition don't have climate science expertise. It uses fake experts or argument from false authority. So, so that's the gist of deconstructing misinformation claims. We then went and applied that to our taxonomy of all the different claims from our cards research, which was like a real pain in the ass doing this work, but because you had to firstly start with real world examples, and then deconstruct them into premises and conclusion, identify the hidden premises. But there were different flavors of arguments under which, because this is a taxonomy trying to cover the whole landscape of climate misinformation. So often it takes different forms, and ultimately we were trying to synthesize them into a single form, if possible. So ultimately we went through this process in order to come up with a generic version of each contrarian claim, and then identify what were the fallacies in each one. So we went through every claim in our taxonomy, deconstructing them to identify the fallacies, and then ultimately creating a summary of here is each claim, each contrarian climate claim, and here is the fallacies in each claim. And then that is a resource that we can then use in our debunking interventions later on. And it also helped us to see what are the main fallacies in climate misinformation. And they are either the top two about how they handle data. So I'm back in Australia, data. And so, whereas the next two were about misrepresenting or oversimplifying scientific systems. So misleading handling of data or misleading handling of systems. Yes.
I love this first description, slothful induction. Could you tell us what that means?
Slothful inductions is coming to a conclusion without looking at the relevant evidence. So you just kind of, and we've got a little icon of a sloth somewhere. I don't have it on my slides, but yeah, it's like an example would be, well, we haven't seen strong climate impacts yet, so climate change is not a problem. And we saw this actually during the pandemic. The first months of the pandemic, they're saying, well, more people die from the flu than from COVID, so we don't need to act on COVID. We don't need to do COVID restrictions. it was ignoring the evidence that there were big impacts coming down the pipeline because COVID was more infectious and more deadly than the flu. And sure enough, like weeks after those arguments were going through, like Fox News and all the kind of conservative media, COVID deaths skyrocketed past flu deaths for the year. So it's similar with climate. They'll say, well, we haven't seen the 1 meter of sea level rise yet, so what are we worried about? Even though the science is predicting that we will see accelerating impacts from climate change. So, and the analogy I use is it's like falling from the 30th floor of a building, and halfway down you say, well, nothing bad's happened yet. It's slothful induction because you're ignoring what's coming down the pipeline. That's one example of that fallacy. So that's deconstruction. Anything else any questions on that before I move on to the third D of the 4 Ds? So this is again a very speculative idea that we're just in the early stages of. And we're calling it generative debunking. The idea that if you want to automate fact-checking of misinformation in real time, which what we call in misinformation research the holy grail of fact-checking, it's not really adequate to just provide canned responses. Like we might be able to detect all the different claims in the taxonomy, and we might know the fallacies in each claim. So we could potentially say, well, this claim uses this fallacy and that's how it's misleading. But just to use that same response in response to any real world example is not going to cut it in practical application. So we're exploring how can you automate customized replies to detected misinformation. Firstly, it's important that any intervention that attempts to do that still follows the best practices from the psychological research into debunking. And we summarize that in the Debunking Handbook, which was published in 2020, which is a pretty concise summary of all the psychological research. Like we just boiled it down to what are the practical guidelines, and the URL is at the bottom there if people want to check it out, or just Google the Debunking Handbook. But you could boil it down to this. Effective debunking needs to really contain several elements. Firstly, you want to communicate the fact, which is going to dislodge the myth. So when you dislodge a myth and you're actually taking it out of the person's mental model, and that creates a gap, and you want to fill that gap with the replacement fact. So if you're saying, no, the sun isn't causing global warming, it's not enough just to provide evidence that proves that the sun isn't causing it. You need to replace that with what actually is causing global warming. Otherwise, people experience the continued influence effect. The myth comes back into their mental model, and they continue to believe it. The other important element of debunking is explaining how the misinformation misleads. And also, it is important to mention the myth when you debunk it. There was a lot of concern about backfire effects, and if we mention the myth, is it going to make people believe the myth more? And I'm kind of partly responsible for that for some of our early publications. But the last decade of debunking research has shown that backfire effects are very hard to replicate, and it's more important to mention the myth in order to activate it in people's minds so that they can tag it as false. But you can mitigate the danger that it might reinforce the myth in people's minds by just warning people before you mention it. And that can be as simple as one myth is that, or there is this misconception that, and that puts people cognitively on guard, so that then when you describe the myth, they're less likely to encode it as a true statement. But once you've communicated the fact and the myth, then you have to help people resolve the conflict between the two. Like, how can these two different conflicting arguments coexist? And the answer is explain the fallacy that the misinformation uses to distort the facts. That's why the fallacy, the deconstruction research is so necessary. And so we've gone through this process of identifying the key fact and key fallacy in all the most common climate myths, and and documented them, communicated them in a very short, snappy way. But what needs to happen now is, if we are looking at automating response to detected misinformation online, we need to take this content and embed it in generated responses. So that's what we're playing around with now, the idea of generative debunking. Can you take like the text of a misinformation post? Like, firstly, here would be the most obvious way that you would use NLP to automatically generate a response. Just say, hey, GPT-3, debunk this statement. The problem is I don't really trust GPT-3 to provide accurate facts reliably, because it's trained on both accurate and inaccurate content. And so I think that you do need to provide a more carefully designed prompt that constrains or guides it on what content to include. So what we're, like an example would be, write a tweet that debunks, here is our misinformation post, but then basically explain the fallacy that the misinformation uses. So you take the fallacy explanation from our deconstruction work and embed that in the prompt. So hopefully you get then you get a more targeted debunking response. And the other thing is there are a few, like there are lots of different approaches that you could take with this. You know, you could play around with different writing styles. So, like, I'm not saying we would necessarily do this, but just trying to illustrate that it is possible to manipulate, like have several different parameters that you might manipulate. Word length, readability level, you can instruct it to write at a 10-year-old level, 15-year-old level, or so on. And what I'm hoping this year is to do experiments where we manipulate several different dimensions and then just see what's most effective. Not quite sure how to, I've never done field experiments. I've always done very controlled, randomly RCTs in the lab. So doing stuff out in the wild is a little bit scary for me, but I don't know if anyone here has that kind of expertise. And to give you an example of a lab experiment that I've done, one of the things that I've manipulated is it more effective to debunk misinformation by putting the emphasis on factual explanation or explaining the technique that the misinformation uses to mislead? So here was some research we published a few years ago with some of my colleagues from the US when I was based over there. And we tested either debunking misinformation by emphasizing the facts or by emphasizing the explaining the technique used in the misinformation. So I don't think we've got time to go into, we're already over time. But let me cut to the final thing. What we found was logic, explaining the techniques of misinformation worked, whether it was a pre-bunking or a debunking, whether it came before or after the misinformation. But explaining the facts only works if the facts was the last thing that people saw at debunking. If people were shown a factual explanation and then the misinformation came later, the misinformation cancels out the facts. So that's a limitation of just explaining the facts to people. Facts can be cancelled out by misinformation. So this is one of the studies that point to the importance of explaining the techniques of misinformation.
Quick question. Was misinformation labeled as misinformation before you presented it?
The way we designed this experiment was we just showed people a series of Instagram posts. Yeah. That's 6 or 8. I forget how many, but most of them were dummy posts, just random stuff. One of them was a misinformation post, not labeled. One of them was our correction posts, and the correction either came before or after randomly. So it was about just showing them lots of different posts and then seeing whether the correction was effective coming before or after, and whether it was facts or logic. And so what we find is logic is more robust in the wild, because the loose interpretation is that logic is about teaching people how to think and assess arguments, whereas factual explanations is just downloading facts into people's heads, which is important, and it's necessary, but insufficient. And I wanted to, can I keep going? Can I go into agent-based modeling in detail? All right. So we're also looking at using agent-based modeling to simulate different inoculation interventions in a social network. And that enables us to simulate different types of strategies to see what's the most effective strategy. So and we're in early days. Our model needs a lot of work, but we started with the idea of, what was often used for doing COVID modeling in 2020 and onwards, where you just have your population divided into people who are either susceptible, or they get infected, or they recover. In this case, they're susceptible to misinformation, or they've been misinformed, or they've been debunked. But we added a fourth group in our model, which was an inoculated group. So in that case, this is a group of being inoculated preemptively. And then how does that affect how the misinformation disseminates?
This is also being recorded, so if you guys have other things on, cut off. But yeah,
right. Okay. So this is being recorded. Good to know. I didn't know that either. So I wouldn't have sworn as much if I'd known that, but it's okay.
it's recorded on the file.
All right. So and I won't go into detail in here, but just the idea is that we have people who are inoculated, but they're also exposed to misinformation, and the way that people move from being inoculated to misinformed, or from misinformed back to susceptible, depends on their social network, who's around them, their pre-existing beliefs about climate change, and their pre-existing beliefs about climate change also influence how they respond to inoculation, how they respond to misinformation. So, so there's a lot of parameters, and we're hoping this year to run experiments that can help us empirically ground these parameters. This is just like an idea of what would happen. So if you start by inoculating like 30% of the population, then you see what happens in terms of once they're inoculated, you do see misinformation spread, but the inoculation can attenuate or reduce. It's basically bending the curve on the number of people misinformed. And we've done some initial playing around with simulating who do you target if you're only going to inoculate 30% of your public. Do you inoculate the choir, the people who are already convinced? Do you inoculate the undecided, or do you inoculate the people who are at the dismissive end of the climate spectrum? And this was a look at those three different scenarios. And we do find that when you target the dismissive, you get a much smaller spread of misinformation. So that basically don't preach to the choir is what what the simulation indicates. And that seems obvious and intuitive in hindsight, but I did have wonder whether preaching to the choir can also teach the choir how to sing, and then they can go out and inoculate other people. So there was a possibility that could have a positive effect, but it's outweighed by stopping the misinformation from spreading in the first place. So that's, again, we're in early days in the agent-based modeling research, early days and everything. But the idea of all of this is to try to synthesize all this research into practical applications. And it actually, it really began when some Berlin-based app developers approached us about creating an app to fight climate misinformation. And then we were just kicking around ideas. And then one of the ideas was, what if you had an app that just identified misinformation on social media, provided a feed of misinformation posts, and gave people the opportunity to debunk them. But if they chose to debunk misinformation, it would provide a suggested debunking post that was not canned debunking, but the text was this generative debunking idea. So it would directly respond to the misinformation post, but also add in the fallacy explanations or the factual explanations or whatever content we supply. So, so this is one idea we're thinking about, and the idea is just make it easy for people to quickly identify misinformation. Perhaps use agent-based modeling to prioritize which posts go first, because if you've got 4,000 tweets a day, that's just on Twitter. If you expand it to all the other platforms, yeah, there's too much tweets to respond to. But if you prioritize the ones that are coming from the influencers, or maybe they're posting misinformation that we know is more viral than other categories, then we could prioritize the ones that could potentially go viral faster, and then try to respond to those as quickly as possible. The other option, is just using some kind of automated response, like bot responses. But I'm not I haven't done any studies on that, so I don't know how well they're received in real world settings. I've been told that bots on Reddit are more socially acceptable than Twitter, but again, that's not my area. So that's everything actually. So happy to answer any questions if people still want to hang around and talk more. Apologies that it's just covering so much rather than deep diving into one single study, but I thought just cover all the different disciplines and then see what people are interested in.
So why don't we compromise a bit here, have one or two questions, but if I understand some of you have other commitments, so if you want to go into that, if you want to charge out, I'm going to trust Sasha is checking, see if there's any questions on Zoom.
There are not. No, there's one. Dan asks, how effective is it to point out the vested interests in the source of misinformation? For example, pointing out climate footprint is invented by energy companies to deflect responsibility.
Yeah, so the question is, what about discrediting the source of misinformation rather than the logic-based or the fact-based approach? Yeah, so I only talk about fact-based and logic-based, but there is a third type of correction, source-based, which is explaining how the source is not a credible source of information. And you could do that by talking about their vested interests or their track record, or other ways that they lack credibility. And I haven't studied that yet because it's a bit ickier compared to the other two from an academic study point of view. But my intuition is that it is very effective, but there's been very little study in it. One of my collaborators, Jeffrey Supran, is actually designing a source-based versus logic-based versus fact-based kind of mega experiment where we're testing that. Yeah, that's so to answer your question, there's really not much data, like quantitative data comparing the relative techniques. There's been a lot of books written about it, like Naomi Oreskes has written her Merchants of Doubt book, and they've just got a new book that came out in the last week that's along similar lines. But yeah, so I apologize that I don't have a definitive answer to that question. Again, early stages. Yes.
It's kind of a slightly two different ways to think about it. But if you consider how sort of spreadable the ideas that come from the debunking methods are. So like your one classic thing about misinformation is it's generally more interesting than the things that come to respond to it. Like and especially with like the logic versus fact-based debunking, I was just wondering, like, for example, it's a lot easier to explain some facts to your friend than it is to explain like a logical system for determining whether something is factual.
Yeah.
To your friend,
So the question is, like, are there different, more effective or spreadable or accessible ways of debunking? Is that the general gist of?
Well, like, is there much like just consideration of sort of how sort of viral the ideas that we're generating as responses are? Yeah, so because misinformation is typically more viral than accurate information. Like I think one off the top of my head, I think one study found that misinformation spread 7 times more than like accurate information. I forget exactly it does, but that idea is communicated in the what we call the golden rule of debunking: fight sticky myths with stickier facts. Like sticky myths are, they grab people's attention, they're more likely to be shared, and they're more likely to be remembered. So it's not enough just to identify that replacement fact. You also need to communicate it in a way that is ideally as sticky, as attention grabbing and memorable and viral
as the myth that we're trying to detect, to debunk. And that's really hard because we're constrained by reality, whereas misinformation isn't. But there are frameworks to make our facts more sticky. Like I found the Made to Stick book by the Heath brothers really useful. Like they have their sticky acronym, success, make it simple, unexpected, take people by surprise, concrete, credible, emotional messages are more viral and memorable, and tell your information in the form of a story. The more of the success boxes you can tick, the stickier and more viral your information is. And if I had time, I could probably give you examples, concrete examples of that. But the one thing we have looked at is using humor and cartoons as a way to make the debunkings more sticky and viral. And also, you said, you're right, explaining logic is difficult. But what my philosopher colleagues introduced to me was the idea of parallel argumentation. You can take abstract logical arguments and transplant them into analogous situations to make it concrete and accessible to people. So this is just taking the fallacy of oversimplification and using it in an analogy. And late night comedians use this technique all the time. And their goal is entertainment, not pedagogy, but they are educating people in misleading fallacies by saying, well, this public figure said this today. That's just like being in this situation. And then they use the same logic. Everyone laughs because it's funny, but they also see how the original argument was logically flawed. So, and similarly, like when we're explaining facts, we often use analogies to explain like scientific systems or just aspects of the real world. So analogies are a way to take our abstract explanations and make them more concrete. And because it's also visual and funny, we have found that the humorous debunkings are much more viral. They get more engagement. And they hold people's attention for longer. And we did mediation analysis in a different study that found that it was through that greater attention that the humorous corrections were more effective in reducing the credibility of the misinformation. So hopefully that answers that question.
Very good answer. Look, I'm loath to cut this off, but I'm aware that we've gone 20 minutes over.